This discussion introduces us to what is a fairly common distributed systems problem. So the distributed systems problem that we're facing is that we have two members of that system, and in this case it's Martin and Grace. And Martin and Grace are both operating on information that is coming from the system. However, they are in disagreement about the state of that system. Martin says that the pine tree fell first, Grace says that the spruce tree fell first. Now, the problem that we have is deciding who is correct. How do we decide whether Martin is correct or whether Grace is correct? The reality is that we can't. And with just the information that we have available to Martin and Grace, we can't determine who is correct. What we have to do is we have to modify this situation in order to make that determination. So the question is, how do we modify it in order to fix the problem? So one option is to embed additional information into the system to provide Martin and Grace with more information than what they currently have in order to help them make the decision. So for example, if Martin knew that he was 340 meters away from the pine tree and he knew that he was 340 meters away from the spruce tree, then he could make a calculation and say that, well, since sound travels at 340 meters per second, and I know that I heard the pine tree, and then 1 second later I heard the spruce tree, I know that the two trees fell at the same time. He would be able to make that calculation if he has enough information available to him. Similarly, we could provide Grace with that information, and then she could make that decision as well. So one option is to embed more information into the system. That's a solution that we use in distributed systems as well. When we send messages between distributed systems, what we do is we will sometimes embed additional information in that message in the form of metadata, which could include things like timestamps, for example. If we have access to timestamps, then we can use those timestamps to potentially reorder messages if they seem to come out of order. We can embed version numbers, which again also allows us to look for things coming out of order. It allows us to see if maybe we missed something. So we're able to use that information to help us as well. So there's ways that we can embed additional information into messages in order to help us figure out exactly what the proper state we should be in is. So another technique that we might use in this scenario is we might introduce a third observer. We have Martin, we have Grace. We could introduce a third person and put them at a different location. When we do that, now there's a couple of options available to us. One is we could just do a best 2 out of 3 sort of scenario. If 2 people say the pine tree fell first, then we just say the pine tree is the correct answer and we move on. We do this in software all the time. We use quorum rules, which basically say we're going to request an answer from a majority quorum of a group. So if you have, say, a group of 5 nodes in a cluster, you would request information from 3 of them, 3 being the majority, and as long as those 3 all agree, then you can potentially use that as the correct answer. So we can use quorum rules in a distributed system. The other thing we could do with a third observer is we could run some sort of more complicated computation. So we could actually take the answers from all 3 people and try to merge them together into something that seems more correct. And we use techniques like this as well in distributed systems. We use things like CRDTs, which we'll talk about later in this course. And CRDTs do exactly that. They take multiple conflicting pieces of information and merge them together into a final answer. So that's another technique that we can use. And then a final technique that we could use in this situation is we could eliminate one observer. So we have Martin and Grace. We could just say that let's get rid of Grace. We'll say that we only accept an answer from Martin. Grace's opinion doesn't matter. And that's another technique that we use, and it's something that we're going to cover a little later again in this course. We do that when we do sharding. Basically what we do is we say that there is a single entity or a single person in this system who will give us the definitive answer. Nobody else's opinions matter, only that piece of the system has the definitive answer. Now, doing that has risks associated with it. If we say that only one person can give us the answer and that person is unavailable, then we can't get an answer. So it has consequences associated with it, and we have to be willing to balance that. But it is an option. We could simply say that there is a single expert in our distributed system. We will ask that expert and only that expert, and nobody else can give us an answer. So that's another approach that we can take. The key here to recognize is that these are all distributed systems problems, but they're also all real-world problems. The example that we give here is a real-world problem, but the solutions that we come up with for that real-world problem are similar to solutions that we would use when we build software. And this goes back to something that I always say about building distributed systems is we should look to how things work in the real world, because that can help inspire our choices about what to do when we start dealing with the software world.